All right, gentlemen, hope you're doing well. We're on chapter 3-6, all right, where we're going to be analyzing lines of fit. All right, and then this lesson, we're going to take what we learned from 3.5 in trend lines and scatter plots, and we're going to do what we did in 3.5, but with a calculator now, okay? All right, so we're going to be using the TI Inspire calculator to make a scatter plot, to create a line of best fit, and then to analyze that line of best fit. We're going to analyze it by finding a couple different things using the calculator. All right, some different measurements and some different data points. All right, they'll be very helpful in analyzing it. Okay, so line of best fit. Line of best fit is the trend line that shows the relationship between two sets of data most accurately. What line of best fit is essentially, it is the most accurate trend line that you could ever have, right? Trend line, all right, that we talked about in 3.5, that's right when you draw the scatter plot yourself and then do the trend line. It's more of a sketch. It's more of a hypothesis, a little bit of an estimate, all right? Your trend line might differ slightly from someone else, all right? Whereas line of best fit is the definitive line of best fit, that best trend line that you could draw that best correlates, best relates to the data in your scatter plot. Okay, there's the correlation coefficient. This is the number that shows how strongly your data is related. Okay, it's the number from -1 to 1 that tells you how closely the equation models the data. Okay, and a number from -1 to 1. The closer it is to -1, the stronger negative correlation that the data has. The stronger the +1 that it is, it's a stronger positive correlation, and the closer to 0 that it is, right? It's more closely, there's no correlation. Okay, all right. So -1 to +1. All right, and this just shows what the correlation is between the data points. Okay, so in this video, we're going to do things a little bit differently. We're going to kind of walk through this together. So I want you to do two things kind of simultaneously. I want you to get your calculator out. We're going to go through this together. All right, we're going to input the data together, and then we are going to make a scatter plot. At the same time, I want you to be copying and jotting down notes about how to do this, so you can refer back to these notes, all right, when you have to do this. Use a calculator to make the scatter plot. All right, so get your calculator out. All right, we're going to input this data here into our calculator. So we're going to start. All right, anytime you're in the calculator as a review, you always want to work on a document. Always be working in a document. Always be working in a document. Don't ever be over here in Scratchpad land. Always want to be in a document. Okay, so we go to New Document. All right, I'm going to add a list and spreadsheet. All right, so you get this spreadsheet. All right, looks relatively similar to an Excel sheet or a Google sheet. Okay, so again, create a new document, add lists and spreadsheet. So these are the notes you want to be copying down, right? And then the third thing we want to do is title your columns with your variables. So my two variables, altitude is my x, temperature is my y. So altitude, and you type here on the bottom of your calculator, this keypad, tude, I can spell. All right, and temperature is my y. Okay, and then I'm going to go through here and enter input on my data. So 0, 59, 0, enter, 59, enter, 500, enter, 59.2, enter, 1,000, enter, 61.3, enter, 1,500, enter, 55.5, enter, 2,000, 41.6, 2,500, 29.8, 3,000, 29.9, 500, 1, 4,000, 2, 500, 12.4, 5,000, and this last one is 0.6. Okay, so once you enter all your data in, okay, here, data, All right, you want to make sure you just go back and then refer to the table, make sure you have all the data points correct, make sure you hit enter on this last one. Sometimes guys will just leave it like this. That messes up the data. It won't read it until you hit enter. All right, make sure all your data lines up. Make sure there's no typos. Make sure your X and Y are properly labeled. Should have about 11 different lines there. All right, and we're good. One key thing, don't ever type in this column here, this middle column. Anything typed in here will kind of populate the entire column. So just make sure you don't type that in there. All right. So next thing, I want to make my scatter plot. So I'm going to go add a tab, essentially, add a page. All right. Any of these commands here in blue above the buttons for your calculator can all be initiated by hitting this control button. So I'm going to hit control. I'm going to add a page. So control, doc, right above there's a plus page. So I add a page. I want to go to data and statistics. Here's the notes for it. All right. Control doc, add data in the statistics. All right. And then you get to this, come to the scatter plot, right? Data everywhere, kind of no rhyme and reason, just everywhere. And what you want to do here is set up your X and Y axes. Okay. So my X variable here, let's go back here, is altitude. X is our altitude. Y is our temperature is a Y. And you can see there, once you set your label your axes here, all right, you have your scatter plot. Okay, you can make a couple of different inferences here, right? You can see clearly that there is a correlation, right? The data is pretty closely together. You can also infer that, it's as X is increasing, Y is decreasing, as the altitude is getting higher in the air, the temperature is going down. That makes sense. Right? So there's a negative association there, negative correlation. Okay, so all things that we talked about in 3-5. All right. Okay, so here you've made your scatter plot. All right, the next thing we're going to talk about is find that line of best fit. So let's find that line of best fit here using the calculator. So I'm going to go to menu. Here are the steps here. I'll let you copy these down. Menu, analyze, click on regression, and then show linear mx plus b. So here, analyze, regression. From regression, I want my slope-intercept equation, mx y is equal to mx plus b. All right, and there pops up your trend line, your line of best fit. And with this should also show up your equation for that line of best fit. So you see the slope is negative 0.0122. That's your slope, right? Your y-intercept is 66.28, right? So there's your equation for that line of best fit. All right, so there's my line of best fit. All right, now let's talk about that correlation coefficient, how we find that. All right, your R value. So I want to add another page. I'm going to go to Control Doc, add another page. From here, I want to go to Calculator. Control Doc, add Calculator page. Click on the VAR button, VAR right here above the 9. I want to click on stat.r. Stat.r, click enter, and there is your R value, negative 0.96, right? So it's a pretty strong correlation, pretty strong negative correlation, right? Pretty close to negative 1. Okay, as we kind of inferred from where the data was, right? Okay, so right, we've made the scatter plot, found a line of best fit, found the correlation coefficient. All right, those are a couple of things that we're going to be asked to do here in 3.6. Again, make sure you get all these notes copied down here for the calculator. All right, but these 7 or so steps. Make sure you have the steps to find the line of best fit, to find the correlation coefficient. Again, just pause the video at any of these to make sure you got it. Okay, now let's take a look at some of the example problems. We're not going to do any more practice problems, just look over some example problems here. All right, you can see this is data that they took from this table. They input it into their calculator. The calculator the book shows is a little bit different than what we looked at. All right, but somewhat similar. You can see that the table here, spreadsheet, you can see they ran a linear regression, a little bit different than what ours looked like, right? A couple steps different, but nevertheless, they were able to find the equation, right, which is important. Okay, Then we have the correlation coefficient. Again, okay. All right, correlation coefficient, you can see here, the closer it is to positive 1 or negative 1, the stronger it is. So you can see here that's a 0.984, pretty strong correlation. Here is negative 0.284, pretty close to 0, and that matches up with the data. It's kind of all over the place. So there's really not much of a correlation there. Right, so it'd be closer to no association. No association. There is a weak correlation there. And then here you can see here's a pretty strong negative correlation, negative 99.5, negative 0.995. All right, the last thing I want to talk about, I want to make sure you copy this down, interpolation, extrapolation. All right, these are, this is important to know because you can see here they have this other scenario, all right, here with years and air miles traveled. All right, and what they want us to do in this problem here is all this data is what has happened. And they want, right, every 5 years they have a data point. They want us to estimate the number of air miles people flew in 2003, which is not one of our points. Right? We only have 2000 and 2005. And then they want us to see if the trend continues, how many miles would people fly in 2030? So we don't have anywhere close to 2030. That's 30 years past any points that we have. So this interpolations, anytime we're copy this down, using a model to estimate a value within the range of known values, extrapolation, using a model to make a prediction on outside of the range of values that you have. So 2030 is outside the value that we have. 2003 is inside our known values. Okay. Again, this started in 1975. And so the number of years since 1975 would be our x variable here. All right, so you would do 2003 minus 1975, which would be 28. Plug that in for x, solve for y. All right, 2030 is 55 years since 1975. Plug in 55 for x, right, you solve for y there. Okay, so this is a little bit why we want to know the equation so that we can, again, we can make estimates, all right, within the range of known values that we have, and estimates outside of the range of values that we have. Okay, all right, so that's about all we want to talk about today here in 3.6. Make sure you have all your notes copied down. We'll go over more of this in class. Hope you're having a good day. All right, we will talk soon. Take care, guys.